Okay, this is our lesson 5D on division of polynomials. We just got done doing factoring, and factoring works well when things break down to nice clean numbers, or nice clean factors, I should say. But if you can't factor it nicely, you could still divide it and have a remainder, just like you would with any other number. So let's go ahead and take a look at just regular division. And we see that in the upper right-hand corner. And what we have here is 235 divided by 12. So what we learned back in grade school is you take 235, you divide it by 12. Okay, and you say, okay, how many times does 12 go into 23? Total of 1 time. You take the 12, and then you subtract it from 23. And what we have here is 115. And say, how many times does 12 go into 115? Well, it goes in there 9 times. So then we go 9 times 2 is 18, carry to 1, and we have 108. So then we say, okay, we have now a total of 7 left over. So what do we do with that 7? We have a remainder up here, and we have 7 divided by what you divided by, 12ths. So 12 goes into 235, 19 and 7/12 times. Okay, so right here is the quotient of what happens. Okay, we're going to apply that same setup to polynomials. So notice here what I have is the polynomial right here. So I'm going to start with that. X cubed plus 5x squared minus 7x plus 2. And I'm going to divide x minus 2. Okay. Now, just like we did with the numbers here, I'm going to look to see how many times does x minus 2 go into this polynomial. So what do you start at? You always start with the first term. And you look, well, how many times does x go into x cubed? Okay. And you think, all right, x times what equals x cubed? Well, that'd be x squared. So where am I going to write it? I'm going to write it above the x squared column over here. So then, just like we did with the numbers, I'm going to take the x squared and multiply it by both the 2 and the x. So x squared times negative 2 is negative 2x squared. X squared times x is x cubed. Okay. Now, notice what we're doing here. You are subtracting this whole polynomial. So when you go through here, you have to switch the signs. Okay, so I'll switch colors again here. And we say, okay, x cubed minus x cubed is nothing. 5x squared minus 2 is 7x squared. So it's really 5 plus 2 there. And you go ahead and copy everything else down, just like you did with the numbers. Now you look, okay, how many times does x go into 7x squared? I'm just looking at the first term right here. You say, okay, it goes in there 7x times. So plus 7x. And I'll now multiply. Actually, let me just redo this in blue, just to keep consistent here. So it goes in there 7x times. And you multiply. 7x times negative 2 is negative 14x. Negative 7x times x is 7x squared. Now again, we're going to subtract this entire polynomial. And what we have here is simply 7x squared minus 7x squared, nothing. Negative 7 minus 14, so that becomes positive 14. So it becomes positive 7x plus 2. Okay? And then you take a look at the last thing. How many times does x go into 7x? 7 times. 7 times negative 2 is negative 14. 7 times x is 7x. And once again, I'm going to subtract this entire polynomial. And we're left with 2 minus 14, which is 16. So we have 16 left over. Now notice, 16 doesn't have an x anymore. So we are 1 degree less than x. Okay? So this is a remainder. We can't divide anymore. So what do we do with that 16? Just like you did with the numbers, you take the remainder and you show it up here. So you write 16 on top of your fraction, and on the bottom, you write what you divided by. So what we have here is this polynomial, okay? X minus 2 goes into this polynomial this many times, okay? Now, what we can do is write this as a factor. So I could say that x minus 2 times x squared plus 7x plus 7 plus 16 divided by x minus 2. If I multiply those two things together, you will get that. Okay? So if you actually distribute it out, that remainder will disappear, and you go back to the original polynomial. So it shows you that you can take any polynomial out of any other polynomial and get an answer. It's not going to be a clean answer. You're going to have a remainder there, but it's possible. So let's take a look here at this example. So here we have 3 terms. So I'm going to do this exact same setup. I'm going to start with 3x to the 4th minus 5x cubed. Just going to write this down. And I'm going to divide it by x squared minus 3x plus 5. Okay, so what we have here is this. I'm going to divide x squared into 3x there, so it goes in there x squared times. Now notice what I did here, okay? I'm going to change my setup. So look at, I have 3x to the 4th minus 5x squared, and then it jumps to 4x. Where did the x squared go? So really, I want to rewrite this portion here. And I'm going to show a different way to write this to keep it a little cleaner. I'm going to show every degree. So we have 3x to the 4th minus 5x cubed plus 0x squared. So I'm putting the x squared term in there as a placeholder so we don't lose it. So now x squared goes into 3x to the 4th. How many times? 3x squared times. So I'm going to put that above the x squared column and go ahead and multiply it out. So 3x squared times 5 is 15x squared. And then minus 9x cubed, and then 3x to the 4th. And again, I'm going to subtract this entire polynomial. So now we're left with 5 minus 9 is positive 4x cubed minus 15x squared, and I go ahead and copy down the rest of the polynomial. Okay, so we're going to go ahead and do it again. So x squared goes into 4x cubed. How many times? 4x times. So 4x. And then go ahead and multiply this out. So 4x times 5 is 20x, and minus 12x squared, and then 4x cubed. Key thing is you always have to subtract this, okay, just like you would in normal division. So 15 minus 12, so it's going to be negative 3x squared. 4 minus 20 is negative 16x, and minus 6. Now notice, I have x squared divided into x squared. So this is going to be my last number because I'm on the last column, the constant column. So we're going to go ahead and say, okay, it goes in there negative 3 times and multiply out. So we have negative 15 and positive 9x, because there's also 2 negatives, and minus 3x squared. Okay, so now when I subtract this last one out, I'm going to subtract it out, and we're going to have negative 16 minus 9x, so that's negative 25x, and negative 6 plus 15 is going to be a positive 9. Okay. Now notice, that is less than what I'm divided by. That is a linear polynomial. This is a quadratic, so I have to write this as a remainder. So this last portion here is my remainder. I'm going to write it up here. So I'm going to say positive. I'm adding something to it. Negative 25x plus 9. Again, you don't want to put that negative out in front because the negative only belongs to the 25x. Okay? And on the bottom, you write what you divided by. So that is the answer to this portion here. Okay? So it says here, write as a product. Okay? So I'm just going to kind of write that up in the corner here. So I could simply say that x squared minus 3x plus 5 times this answer of 3x squared plus 4x minus 3 plus negative 25x plus 9x squared minus 3x plus 5. Okay? If I multiply that out, you will get that. Okay? So when it says write as factors or write it out, that's really good. So I did factor it, not cleanly. Okay, we have you know, a fraction in there, but it still works. All right, so let's talk now about a shortcut. This is called synthetic division. So it's doing the same thing. So notice this is the exact same problems we did in the very first slide. Okay, this only works when you have a linear factor, meaning x to the first power, and that is all by itself. There's no x squared or anything here. So this only works when you talk about single solutions, single factors. Okay, and what you do is you look at the quotients of this. So I'm going to start with, okay, I'm going to write down every single thing. So I have 1 for the x cubed column, 5 for the x squared, negative 7 for the x, and 2 for here. And you actually kind of go upside down here a little bit, and we're going to start like this. Now, if I said solve for x minus 2 and you set it equal to 0, what do you get? You get x is equal to positive 2. So I'm going to switch the sign right here and put positive 2. So you need to switch the sign. Okay? So I'm going to put a little note here. Right here. Okay? Now, this is a pattern, so that you want to pay attention here and make sure you're doing this the correct way. Very first thing you do is bring down the first term. So 1. Any number on the bottom, you multiply by the 2. So 2 times 1 is 2, and you write it into the next column. Anytime you have a column, you add. 5 plus 2 is 7. It is now on the bottom. So then you multiply back towards the front. 2 times 7 is 14, and you write in the next column. We have a column again, so we add. Negative 7 plus 14 is 7, and 7 times 2 is 14. And then we say 2 plus 14 is 16. Okay? Now, what do these numbers mean? What we did is actually divide it. So now we look at this. We started with an x cubed, and we say, okay, since we divided by 1x, this first column should be x squared. So I'm going to write this as 1x squared plus, and then we have a 7, so that's 7x. I'm dropping 1 degree. Plus 7, and the last number, this is the remainder. Okay? So we say plus 16 divided by x minus 2. Okay? So all I did was work with the coefficients, similar to the matrices, where you ignore the letters, but you look at the position. So if you look at the very first slide we have the exact same answer right here. And notice it's a lot quicker process. Okay, so it's good to use synthetic division. So again, write as a product. We did it on the first slide, so I'm not going to rewrite it. So I'm just going to put a little note here, first slide. So I did it there as well. Okay, remainder theorem. Okay, what this says right here is, I'll just kind of verbalize it, is that if you take 2 and you plug it into this equation, you evaluate it. So you say f of 2, and you plug it in, what do you get? You get the remainder, 16. So if this is a point on the graph, it's 2 comma 16. Okay? So what's that tell us? If this remainder goes to 0, then we have a solution. We're going to see on the next slide. So the remainder theorem is a way to evaluate quickly the function. So you plug 2 into the equation, or into a function, and you get 16. And that is off the remainder. So let's take a closer look at that here in our next slide. So here we're going to try to find a solutions using synthetic division. I want to factor completely the same elements. So let me just move this box over because I'm going to need that here in a little bit. So again, I'm going to set up my thing. So I have 1, negative 6, 5. Kind of look how quick this goes. Set up my bracket. We have x minus 4. So I'm going to switch the sign and put positive 4. Okay, I'm going to bring down the 1, multiply. Put it here. Add, multiply. So 4 times negative 2 is negative 8. Add, multiply. Now notice here, 12 plus negative 12 is 0. So my remainder is 0. So what's that really mean? That really means that we have, if we plug in 4 into this function, we get 0. So what's that at the point? 4 comma 0. This is a solution because it's an x-intercept. So when your remainder goes to 0, that's a way to indicate it's a solution. Okay? So let's take a look here. Let's just write this as a factor. So what we have here, I started with x cubed, so I'm going to go x squared minus 2x minus 3. And if I write it as a factor completely here, I'm going to do x minus 4. Okay? So there is a factor product. But notice, knowing what we know about quadratics, can we go ahead and simplify that? Well, we can. So we can say this is x minus 4, and let's factor the back half. Two numbers that multiply to 3 to add to 2. We're going to have x minus 3 here and x plus 1. Okay? Now notice, that is a factor complete. So some factor division is a good way to break something down if you know where to start. Okay? Now, I'm going to show you a shortcut here as well, and I'm just going to move this off of here. And since we have the factor product on there, I'm going to delete that there. I'm going to show you how we can divide this out and this out of the same product up here. So what I'm going to do here is divide out negative 3. So I'm going to change this to a positive 3. And I'm going to divide this. Bring down to 1. 3 times 1 is 3. Negative 2 plus 3 is 1. Multiply and add. And notice we have 3 and we have a 0 again. So we have another solution. So what's left over? This is simply x plus 1. And notice it's the last factor. So the solutions are going to be 4, 3, and negative 1. Okay? So this is a very quick way to break down a polynomial. And looking at it in factors and using synthetic division to break it down linear term by linear term. Okay, so here we have 2 equations for you to try. I want you to do long division for the top one. And you can go ahead and use synthetic division for the bottom one. And then after you divide it out, then take a look and say, how can I break it down even more? Okay? And factor completely. So those are the 2 elements I want you to try for our next period.